Hey guys, today I want to present you the 4CoreDual-Sata2. A very nice mainboard for retro computing from Windows 98 and on, also for Windows XP, for Windows 7. Very flexible board. And I want to give you an overview about the specs, what you can do with this board, some trouble you will facing with this board, especially with the SATA 2 version. There are some special problems with this version in comparison with the older version without SATA 2, the VSTA version. Nevertheless, it works great if you know how to. I will show you how to configure this board. I will discuss some CPUs with you, how good they perform. Later, I will show you some benchmark results. I will also make an example, show you about the BIOS settings, how it gets stable, and how you can overclock also with this board. It's not a very good overclocker, but it can reasonable overclock with FSP 200 CPUs. Yeah, and also a short hint about the VI-MODs, but I don't really like them. So let's start with the specs of the board. It's Sockel 775. Yes, clear. It can handle nearly every Sockel 775 CPU that is out. Pentium 4, Pentium D, no problem. Core 2, Core Quad. Nearly the only limitation I know is that, yeah, for sure, more than an FSP of 266 or quad pumped 1066 is not supported. Yeah, you can overclock up to about 290 megahertz. But for sure, a CPU with FSP 333 could not really be used, especially not at full speed, so it gives not so much sense. Perhaps the extreme versions, because the extreme versions have an unlocked multiplier. Yeah, then you can compensate this with a higher multiplier, but yeah, else it doesn't really give sense. It supports double date rate 1 and double date rate 2 memory up to 4 gigabytes with beta BIOS, but usable only about 3 gigabytes because the chipset is limiting to 32-bit address range. So it's like with a 32-bit operating system, but it's in hardware, so it does not change anything if you install a 64-bit operating system. The problem is here inside in the PT880 Ultra chipset of VIA. Yeah, so all in all, about 3 gigabyte are usable. With a GT240 from NVIDIA, I can use about 3.2 gigabytes. If I use 2 graphics cards, yeah, we have 2 graphic card slots. That's for sure a very special thing at this board here. With PCI Express, only electrical connected with X4. And additional, we have an HEP slot. Yeah, that's why it also is very great for a retro computer. Yeah, but if you use 2 cards, I had the experience that then you have even less usable memory with the NVIDIA GT240 and an additional Radeon 9600. I had only about 2.5 gigabyte left with an FX 5500 instead of the Radeon card. I had 2.8 gigabyte left usable. So a significant better result. So yeah, you have to figure out a good combination here if you want to use multiple graphics cards and want to have the maximum of memory. For Windows 7 it's useful for sure. So yeah, I think we don't need to discuss about I/O. We have IDE, SATA, and here, yeah, normal I/O of the time, USB 2, fast Ethernet, yeah. One thing is that's interesting. The capacitors here, the electrolytical capacitors, these were the last one. Later, they only use solid caps, and yeah, they are not that good. They can fail after some years if you use high power CPUs. If you don't, they will at least last about some years longer, but after more than 10 years now, expect that they are not that good anymore. Short discussion about the used components here. As I already mentioned, GT240 passive cooled, very efficient, great for games I think up to 2007, 2009. Later, it's not that powerful. Yeah. Yeah, for the OS for sure. I use this little adapter here. With this, you can simply use your M.2 SATA SSD from your laptop for your retro computer for cheap. Very nice. I use a set of Kingston memory here, 2 times 2 gigabyte. Yeah, nothing really special. And normal cooler, I have it from an OEM PC, works great with Quadcore. So yeah, no need to change. So let's come to the configuration. This board is a bit special, and that's because of the clock generator. The clock generator is here, this piece here, and it is an ICS chip here. The older versions, can you see it? I hope you can see it, but you should see the logo. It's an ICS clock generator. Older versions like 4CoreDual-Sata2 sometimes use a Realtek chip, and the Realtek chip works great, and the ICS chip works not that great. You need to know how to handle this thing. For sure, you should use the latest BIOS 2.20A. The A is important. That's the beta BIOS. Only with beta BIOS you can use 4 GB of memory. Only with beta BIOS, I think AST energy saving feature is available. Fan control is available also, I think, only with beta BIOS, but for me the fan control doesn't really work. In BIOS it's working, it's really slow and looks for me not pretty good programmed, but outside of the BIOS in Windows 7 it doesn't work at all. The temperature increases, nothing happens, cooler still runs slow, so my experience, forget about the fan control. Use something yourself, mod something, or use a continuous speed or whatsoever. But with the built-in, forget about it. Back to the clock generator. This clock generator has an issue, but I think it's more an issue in the BIOS of ASRock, but it doesn't care at the end. At the end, This clock generator has the problem if you overclock your CPU, which should work very good with a Core 2. Core 2 generally overclock very well. And if you use one with 200 FSB, you would expect this mainboard can handle FSB 266, so it should be no problem to overclock it. It is with this clock generator. I think it doesn't change the dividers between FSB, memory, and PCI Express, AGP. It should change it. You can fix PCI Express and AGP frequency, but it doesn't work. Let's say as it is. It doesn't work. You can easily see that this thing here doesn't work, right? Because you can use a workaround here. You can use the BSEIL mod. This mod changes the detected FSB. And if you connect these two pads, this is Pentium dual-core E5300, FSB 200, and if you connect these two pads, and it's very easy to connect them, you can simply use some silver conductive color, and you can try it multiple times. You can easily remove it with alcohol or isopropanol, I think also works. You can easily remove it, try it again, remove it, try it again, until you get it working. Yeah, then it's not really a problem. And then, that's the point, then you see, the modded CPU for FSB 266, build it inside, and it works perfectly fine with FSB 266. Overclocked 33%, and it works perfectly. So the board can handle FSB 266, yeah, for sure. It should, it is specified for 266, and the CPU also has no problem with it. But the combination without the mod, forget it, it will not work. So there's obviously a mistake inside this board, BIOS, blockchain, whatsoever. But the good message, you can work around with this little modification, and then it works perfectly fine. Also in the other direction, if you want to underclock, that's also sometimes interesting for retro gaming. If you want to make your system slower, you can with FSB 266, no problem. It works perfectly fine. All I did is fixing PCI Express and AGP frequency, and then I put down the FSB frequency down to 120, and it was stable. At 100 it was not stable, but yeah, for sure this mainboard is designed for 133 and more, because 133 quad pumped 533 is the lowest official FSB on this platform, with Pentium D, for example, 805 that uses this low FSB, and some Pentium 4. So yeah, nothing wrong if it does not support an FSB of 100 stable. Yeah, but this mod, very important on 4CoreDual-Sata2 with this clock generator. Else, strange behavior. For sure, if you only want to let it run at the stock FSB, it's fine. Then don't care about what I told you now. But if you want to change it, overclock, underclock, then this is really a great thing. Let's come to the BIOS configuration. First of all, as I already told you, use BIOS 220A for EIST, fan control, and especially 4 GB memory. Set the PCI Express frequency to synchronous for an FSB higher than 266. So if you want to overclock, especially a 266 FSB CPU, set the PCI Express frequency to synchronous, else you can let it on auto. For underclocking, for example, for old operating systems, if your system should run slower, fix it to 100. Set DDR2 memory to 533 MHz, especially if you use an FSB 266 CPU. Else, you have to try out what is faster, but for FSB 266, the fastest setting is 533. And additionally, you can also then overclock without any problems, because here you have some room. Let the wheeling speed to normal, because with high you can get data corruption, especially with overclocking. But even if you don't overclock, I would recommend let it on normal, as you will not profit if you set it too high. With the IDE drive strength, it could be possible that you have to set it too low if you have some issues with burned CDs or something like this. The VHEP, set it too high if you have any system instabilities, because it does not only help with HEP cards, because there it increases the voltage for sure. It also increases the voltage of your north bridge, because this is supplied by the same supply. So even overclocking should be better with VHEP too high and general system stability. For the DRAM voltage, use normal or high for double date rate 1 memory and low for double date rate 2 memory. The background is easy. Low means the normal specified voltage. For DDR2 that's 1.8, and for DDR1 it's 2.5. And normal increases the voltage to 2.6, so 100 millivolts more, and the same with DDR2. So there you have 1.8, 1.9, or 2.0, and with DDR1 you have 2.5, 2.6, and 2.7 volts. And yeah, for DDR1 it's helpful to have a little bit more voltage, because there you are at the limit of your memory. But for DDR2 it doesn't really give sense, because even normal memory sticks can easily handle 600 or 800 megahertz at 1.8 volts, so there's absolutely no reason to increase the voltage here. The pipeline DRQCTL should increase a little bit the performance if you enable it. Then very important for modern NVIDIA PCI Express GPUs, disable PCI Express downstream pipeline and PCI Express VC1 request. As I know, it should be important for the GeForce 400 series. For the GeForce 200, I had no problem with my GT 240. But try it out if you see any problems with your graphics card, graphics issues whatsoever, try it out. For Radeon cards, I think it's not important. And an additional hint, PCI Express 3 cards should not work on this board. I read from different persons that no one up to now gets a PCI Express card of version 3 running on this board. If you get this, let me know. But else, I recommend only use PCI Express 1 or 2 cards. There are some compatibility issues with Radeon X cards of the X series, X800, perhaps also X700, especially on HEP. I read about this in the internet, and yeah, I can add also with my PCI Express X800, I had some graphic issues during boot up Windows 7. After the boot up, I saw no problems anymore. Then it worked fine. I could run 3D Mark, no problem. Works perfectly. Yeah, but I think during initialization, it looks like there is something not 100% right. And also an additional hint, disable speed step if you want to change the CPU ratio, else it's not possible. You will see it in the BIOS later. And for Pentium 4 and Pentium D, you cannot change it at all in the BIOS, but you can change it later in the operating system with Crystal CPU ID if you enable, I think speed step must be enabled, yeah. Now let's move on to practice. First of all, I load the BIOS defaults. First of all, in most cases, I enable this because I have a USB keyboard, and sometimes in BIOS during RAID BIOS configuration or before Windows boots, I cannot reset the system with my keyboard anymore if I do not enable this option. So for USB keyboard, I recommend this. I normally disable these things here. If you don't need it, I also recommend disable them. Floppy, yeah, sometimes. Depends if you want to use Windows 98. I think that's interesting. Here we don't need to change anything. This depends. You can use RAID mode or non-RAID mode. That's fine. For the chipset configuration, for me, memory is normally configured fine. So normally I do not change anything here. Here we can enable this. This can be set to high to get the system normally a bit more stable. For sure, you can use here whatever you want. The rest should be fine. Here, normal. And that's it. For sure, you can also disable LAN or HD audio if you use a dedicated card. So now let's come to the CPU. As you can see here, here you can see it. I have a Extreme Edition with max unlimited ratio. To change the ratio, first of all, you have to disable the speed step. So now you can change it like you want it with plus and minus. Simply set up here. We start with, yeah, let's start with 11, I think, 12.5. This should be a good speed. So that's it. I have now a quad core inside. So overclocking is a bit difficult. This mainboard, this chipset is very limited. Even with dual cores, you can overclock only up to about 288, 290. And with quad cores, it becomes even worse. ASRock defaults the CPU even lower and sets with quad cores only about 250 megahertz FSB. Not on my board. On my board it's 266. Don't ask me why, but you can read it in the internet from many other persons. And yeah, if your system is unstable with quad core, then go a bit lower with the FSB. If you now want to overclock, you have to set this to synchronous with FSB 266 CPU and this to this. And now you can overclock. Theoretical. In this case, I would be really careful because I have a quad core. With a dual core, you can simply set now 288, for example, and it should work. So let's try it out. Yeah, you can also see the CPU and then start memory. Hardware monitoring, you see the CPU runs relatively cool. Yeah. So, and as we can see, it starts up, and the speed of about 3.4 gigahertz is a bit too much if you use a quad core on this board without voltage mod. Yeah, but it starts at all, and you can see how you can change the settings, and it is working fine. If you want to underclock, for example, to 120 megahertz, I think that's, for example, interesting. If you want to use an old operating system that doesn't like too high speeds, yeah, then you can simply clock it down here. And here, important here, set both to fixed frequencies, else I think you could face some troubles. So let's try it out, and it should work perfectly fine. As you can see now, I had to increase the FSB a little bit more to 125 to get the system here prime stable. Here, but nevertheless, even then with 750 megahertz, it's a really slow system now, especially for XP, but also usable for Windows 98. Should be a bit like a Pentium 3. You can also see in the system information viewer here that we have very low temperature. Very nice. And I think also interesting is the point memory here. Then it states that the DRAM frequency is really 125. So with double date rate 2 memory, the real frequency should be 250 megahertz, which is really, really slow. I think the lowest specified is 400. So yeah, you cannot even get here a slow system on like Pentium 3 speed, but even the memory is also relatively slow, should be slower than double date rate 1 memory with 266 megahertz, which was up to date, I think, in about 2002, something like this. Let's come to the next topic, Windows 98. Does it run on the 4CoreDual-Sata2? Short answer, yes. You can build up a Windows 98 system on this main board. I recommend to use the chipset driver 4.56 and for RAID a later driver. You have to use the RAID mode if you want to use the SATA ports, because there is no IDE compatibility mode on the SATA 2 version. I recommend to install at first the updates and later the drivers. I recommend use not more than 512 megabytes during installation, else you can face some issues. It makes life easier if you only install 512 megabytes or less, then you can be absolutely sure that no problem comes from this side. And the really most important point, make backups. I installed on a second hard drive Windows 7, and then you can easily make backups. It needs just 1 minute, and then you have a backup, and I recommend make a backup after every step. After the installation, backup. Then the first updates, backup, some drivers, backup. And if something goes wrong, you can easily go back to the last step, or if some drivers are uncompatible, no problem, go back to the last step and try again. So that's, I think, the most important point, make backups. Yeah, short conclusion, you have drivers for everything on this board besides the HD audio for Windows 98. So yeah, you can make a very great Windows 98 build with this main board. A small addition, the AGP performance under Windows 98 looks like it is a bit worse. I don't know 100% why. In principle, it's a native AGP port, so there should be no problem. But it looks like the scores, for example, in 3D-Mark, are a little bit lower than on earlier boards. Looks like small driver issues, but nevertheless, you get great performance. And that's how it looks like with Windows 98 installed, and I let run 3D Mark 2001. you see the result in the upper right side. Let's come to the VMODs. There are 4 main voltages that can be modded on the mainboard, and I will post you the links in the description. A short overview. Let's start with the Vcore. This is the voltage for the CPU itself, for sure. You can mod this on 2 ways. You can change a resistor directly on the mainboard, or you can make the so-called VID-MOD. This mod is very similar to the BSEL-MOD. So you have to connect some pads of the CPU or isolate some of the pads, and then the mainboard thinks that you installed a CPU that need a different voltage and therefore changes the voltage. So very similar principle. The next voltage is VTT. This voltage is used for the FSB. So increasing these voltages can offer you higher FSBs. The next voltage is the VAGP. This voltage is not only used for the AGP slot itself, it's also used to supply the north bridge. At least some parts of the north bridge are supplied by this voltage. And yeah, therefore you can also reach higher FSBs, perhaps also memory clocks, by increasing this voltage. But be careful, if you increase it too much, the MOSFET between the PCI Express and the AGP slot can get very hot, so keep an eye on that. The last voltage is the VDDR. This voltage is for the memory. In the end, yeah, you can also change this voltage, but this is really useless, especially if you use DDR2 memory, because you can already set a voltage of 2.0 volt, and this is more than enough for DDR2 memory, especially on the low speeds here that are supported on this board. Let's have a look on the CPUs that I benched for you. First of all, I have a Pentium 4 and a Pentium D. They are more or less like a reference. Then we have the more modern CPUs, Celeron E3400 and Pentium dual-core E5300. These CPUs are both clocked on an FSB of 266. And if you now ask why, the answer is easy: because I can. Yeah, they are stable, and why not using it? As I described before, you have an issue with the clock generator with lower FSB. So it gives perfectly sense to use the higher FSB, especially you get also more performance, and it's perfectly stable. They have a lot of room, so I perfectly recommend using this option to make the BSEL mod and use these CPUs at higher speeds. And also keep in mind that you can simply use Pentium dual-core of the E5000 series, make the BSEL mod, and then you have a superior CPU in comparison with the Pentium dual-core E6000 series, and especially the higher clocked versions are also not super cheap, so you can also get a cheaper solution that performs better. As a reference for 200 MHz FSB, I have also an Pentium dual-core E5800, then also a Core Duo E7600. This CPU is very nice because it has 3 MB of level 2 cache. The Pentium dual-core has 2 MB of level 2 cache and the Celeron only 1. So we can also see what's the influence of the cache. And I also benched all 3 CPUs at the same speed so that you can directly compare them clock for clock. Last but not least, I have 2 Core 2 Extreme quad cores. extreme version is here important because there are no quad cores with an FSB of 266 with high clock frequency. So the only option to use a high clocked quad core on this mainboard is using an extreme quad core with unlocked multiplier. And these two CPUs are also interesting because here you can compare the Conroe with the Wolfdale architecture. Now let's come to the benchmark results. First of all benchmarks were done with Windows 7 32-bit. The first benchmark was VID-MOD 2001, and you can directly see this benchmark is CPU limited. And what you can also see is it likes caches. You can directly see this at the Core 2 E7600, which performs better than all Pentium dual core, even if they are clocked higher. The quad cores are even faster, and yeah, they have even bigger caches. VID-MOD 2003 is clearly GPU limited. You can see nearly all CPUs get very similar results. The only exception is the Pentium 4. Now we come to VID-MOD 2005, and it's now a bit different. The GPU limit is not so hard anymore. We see that even the Pentium D is much slower than the Celeron or the Pentium dual cores. Nevertheless, all faster CPUs perform nearly the same. We have now no big differences anymore because of the cache. The fast clocked Pentium dual cores are even faster than the Core 2. And even the quad cores are a bit slower than the overclocked Pentium dual cores. Now let's come to Cinebench. Cinebench just shows us the raw performance, and yeah, therefore all Pentium dual core and the Core 2 have nearly the same result at the same speed. The Celeron is a bit slower. It looks like 1 megabyte cache is not enough here. The Pentium 4 and the Pentium D for sure are much slower. This was expected. And the quad cores are in a league of its own for sure because of their 4 cores, and they can use them perfectly here. And finally, in Passmark, we get very similar results than in the Cinebench, but the differences between the different architectures, for example, NetBurst and Core, and Conroe and Wolfdale, which are both Core, the differences here are now a bit bigger in the CPU test of Passmark. Now let's come to a short conclusion. On this board, you have a great range of CPUs that you can use. And yeah, after all benchmarks and also after personal use, would recommend a Wolfdale CPU because they are the latest ones for this mainboard for sure. And they work perfectly fine, have very great performance. In most cases, I would say a dual core is enough, and you can clock a dual core higher on this board because of the limited voltage regulators. So yeah, a dual core, cheap and great option. Alternatively, you can also use a quad core for sure, but this is much more expensive. One final hint that you cannot see in the benchmarks: the Conroe gets much hotter than the Wolfdale quad core. So the Kentsfield was much hotter than the Penryn's quad core. There's a very, very significant difference in efficiency between these two. So I clearly recommend use Wolfdale or Penryn and not Conroe. There's a really big difference. I couldn't believe it, but it is. You can directly feel it if you touch the voltage regulators. They are much hotter with the QX6850.